The atoms in your body, the nitrogen, the iron, the carbon, all of this is traceable to the cosmic crucible deep in the centers of stars. A physicist or cosmologist will probably point to some equations and discuss the Big Bang theory if you ask them about the origins of the cosmos. It is a scientific theory that has been refined over the years regarding how the cosmos first came into existence. However, recent James Webb Space Telescope discoveries have raised some doubts about the precise chronology. The telescope is currently returning the best resolution images of extraterrestrial phenomena that have ever been captured. These images indicate galaxies developing much earlier than was previously thought to be possible, startling scientists with new information about the universe. What has the James Webb Telescope found, and how has it changed our understanding of the Big Bang? Let's find out. We are insignificant in the vastness of the cosmos, mired in the everyday grind. We now know that these celestial wonders are made of the same atomic building blocks as us. Thanks to the wonders of science and technology, we discover the mysteries of the cosmos when we gaze into the depths of time itself through our telescopes. And as we search farther back, we move closer to the far-off beginnings of our universe. The Webb telescope has discovered mysteries that contradict everything we previously believed to be true about the early universe because of its unmatched infrared vision. Yes, the Webb telescope's groundbreaking finding has made the universe a whole lot more puzzling. Thanks to the most recent findings from the James Webb Space Telescope, we now understand that the initial galaxies in our universe formed startlingly quickly. Is the distance between the galaxies that the James Webb Space Telescope, JWST, is observing in the early universe truly as incredible as we believe it to be? So far, the answer is unambiguously affirmative. An astronomer at the University of Texas at Austin named Stephen Finkelstein claims that the vast majority of these galaxies are being confirmed. It implies that everything we observed over the summer, including the possibility that the cosmos was skilled at creating stars at a young age, will hold. During the summer of 2022, JWST ushered in a wave of new understandings. JWST was launched in December 2021, and after more than 6 months of commissioning, it turned on fully in July 2022. Soon after, its unmatched infrared sensitivity discovered the faint glows of galaxies that appeared to have originated just hundreds of millions of years after the Big Bang and were thought to be from the distant cosmos. Such historic findings had been anticipated to appear more gradually by astronomers. The amount of data exploded because researchers employed a creative shortcut to measure galactic distances. Those early results were obtained so rapidly. Astronomers typically determine cosmic coordinates by carefully measuring redshift, which is the result of the universe's expansion, stretching a galaxy's light toward the red end of the electromagnetic spectrum. But to do so calls for the laborious and complex process of spectroscopy, which involves gathering and examining a galaxy spectrum. Instead, JWST's fire hose of discovery was driven by simpler, quicker photometry-based methods that simply use observable fluctuations in galaxy brightness to infer their redshift. The spectroscopic results have only recently started to trickle in, whereas the photometric results came thick and fast last summer. However, even with only a dozen or so candidates' spectra-based distances at their disposal, researchers have already discovered that the majority of measurements agree with the first photometric findings. 4 additional galaxies discovered by the JWST Advanced Deep Extragalactic Survey, JADES, have one of the most recent distance estimates that support earlier distance estimates. One of the 4, with the slightly awkward moniker JADES GS 13-0, is the farthest away due to its 13.2 redshift. We are viewing the galaxy as it was 320 million years after the Big Bang. The fact that the galaxy is the most distant object currently known in the universe due to its high redshift, illustrates why astronomers are so excited. Webb appears poised to shatter this record again soon. We can now say with certainty that we are exploring a period of the cosmos that no human has ever seen before. It's astounding, says Yale University's Peter van Dokkum. He eloquently points out that this galaxy is only 300 million years older than the total period sharks have lived on Earth. However, not all high redshift candidate galaxies have been so fortunate, emphasizing astronomers' initial caution. Just 240 million years after the Big Bang in July, Finkelstein's Cosmic Evolution Early Release Science Survey, CEERS, discovered a potential galaxy with a redshift of 16.4. Later, spectroscopy has demonstrated that this deduction was incorrect, as was made clear in research headed by Pablo Arambula in late March. The galaxy is actually a dusty imposter at a redshift of 4.9 or 1.2 billion years after the Big Bang, which is still spectacular but not quite record-breaking. Early photometric analysis is likely to have been confounded by high star formation rates. The good news is that it seems that this galaxy is a unique case. In particular, 2 additional candidate galaxies were found not to share the issue, according to the same study. One of them is Maisie's Galaxy, which was named after Finkelstein's daughter and is visible at a redshift of 11.4 or 400 million years after the Big Bang. Science can now more thoroughly examine these galaxies' ramifications now that they have been confirmed. Smaller than the Milky Way by a wide margin, these galaxies are tiny. However, some appear to be extraordinarily bright and massive and have tremendous rates of star formation comparable to that of our galaxy, which produces about 1 new star per year. The galaxies show galaxy formation began earlier and progressed quicker than expected in the universe, which physicists had previously projected began churning out galaxies at the ripe age of 1 billion years after the Big Bang. However, they do not yet pose concerns for the leading cosmological models. Massive galaxies are expanding quicker than we had previously anticipated. Some of these young galaxies are thought to be only a few tens of millions of years old. This may have effects on the nature of dark matter particles, as well as the huge dark matter structures known as halos that shaped early galaxies. There are still several questionable and possibly model-busting early universe candidate galaxies. Have predicted for a galaxy with this many stars, this, according to researchers, may be the reason it ceased generating new stars. Massive amounts of high-energy radiation are released during the formation of supermassive black holes, which can burn up galaxies and force the gas out of them. As stars originate when clouds of dust and gas inside galaxies collapse under their own weight, this may have stopped star formation in the galaxy. Karina Caputi, a PhD candidate at the University of Edinburgh, originally identified GS 9209 in 2004, while under the guidance of professors Jim Dunlop and Ross McClure at the School of Physics and Asen Romy at the University of Groningen in the Netherlands. Caputi is currently a professor. Galaxies were expanding earlier and larger than we had previously believed during the first billion years of cosmic history, according to evidence from the James Webb Space Telescope. This research provides the first in-depth examination of the characteristics of these young galaxies by tracing the development of the galaxy, which formed as many stars as the Milky Way in just 800 million years after the Big Bang. It was a major surprise to find a massive black hole in this galaxy, which supports the theory that supermassive black holes are what prevent star formation in young galaxies. When we thought the situation couldn't possibly be any more confusing, Webb comes up with another. Yes, astronomers have recently made a groundbreaking discovery, a little galaxy that is a star-forming powerhouse. The galaxy is rapidly producing stars, having formed only 500 to 550 million years after the Big Bang. The astronomers who made this discovery are perplexed. How is it possible for a galaxy this small to create stars at a rate that defies reason? It's a puzzling conundrum that threatens to challenge everything we believe to be true about the origins of the cosmos. What is this enigmatic thing? A galaxy, or something completely different? It's too big to be a star cluster, as some experts have speculated. Our standard universe model, which has done a great job of explaining the universe, does not account for these anomalies. Is it possible that the physical rules were different before the beginning of the universe, or is our knowledge of science still lacking? One hypothesis is that these enormous and brilliant early galaxies were created as a result of an unidentified mechanism that accelerated star formation. Another idea is that large galaxies formed as a result of black holes that expand quickly. How, therefore, could the black holes expand so rapidly? Astronomers will likely continue to speculate about the mysteries of the early cosmos until the solutions to these questions are discovered. It is astonishing that Nobel laureate Roger Penrose thinks that black holes from an earlier world that was already massive may have accelerated the expansion of our cosmos. Penrose has seen bright patches in the CMB that might be radiation from old black holes that existed before our universe, and the Webb telescope's most recent findings are strengthening his cyclic universe idea. It is still unclear if the expansion following the Big Bang was actually sped up by black holes from the prior universe, or whether there were other as yet undiscovered mechanisms. No hypothesis so far has been able to properly explain the erratic behavior of the early galaxies following the Great Bang. It's time to think about alternate universe creation hypotheses to explain the early stages. At this point, the typical model appears to be at a loss. The cyclic universe theory postulates an endless chain of universes connecting to one another. Therefore, if it is true that black holes from a previous world did in fact quicken the early universe's expansion, then we will never be able to trace the universe's origins. There are alternative creation ideas to the Big Bang theory, including the black hole universe, the multiverse, and the static world. It is astounding that the James Webb Space Telescope can view so far into the cosmos. We can now observe objects that were previously inaccessible to telescopes. In essence, it provides a glimpse of the early 500 million years of the cosmos. Astronomers are now achieving their long-held aim of getting their first certain peeks into a period of the universe that has never been examined. Who knows how far we will be able to see? Maybe galaxy creation began 180 million years after the Big Bang at a redshift of 20, a period that was difficult to comprehend until JWST. But if the telescope has taught us anything, it's to prepare for the unexpected. Thanks for watching.